Hello everyone, this is Yogesh Bhute and today we are going to study the convolution representation. Let's see the topics of this particular section. Discrete time unit impulse response. What is the discrete time unit impulse response is? Consider the discrete time serial input serial output system where the x of n is the input for the system and y of n is the output for that system. If the input of the signal is x of n equals to del of n and the system has no energy at t n equals to 0. The output y of n equals to h of n is called as the impulse response of the particular system. So when the input is del of n and output is h of n, its system is called as the unit impulse response of that particular system. So once you know the unit impulse response of that particular system, we can describe the functionality of that particular system by using the mathematical tool that is called as convolution. Convolution having two types, which is convolution sum and convolution integral. Let's see the convolution integral. This is the particular summation is called as the convolution sum is y of n equals to summation I equals to 0 to infinity x of I into h of n minus I, which is called as the convolution of that particular equation. Let's see the block diagram representation of discrete time LTI system is. Since the impulse response of h of n provides the complete description of the discrete time LTI system is when the x of n is the input for that particular system and y of n is the output. For example, the convolution of a two rectangular pulses is. This is the pulse p of n is given as a causal signal. Let's see the convolution sum of that particular signal is. Here we are considering the folded pulse v of minus I. So the signal is having 0 to minus n or 0 to minus 9 here in the figure number 3.4. Now we are going to consider here sliding v of n minus I over x of I. So you can observe here, if you multiply both the signal here, you will have the directly 0 to n pulses remaining. Next pulse here, sliding v of n minus I over x of I. If you continue this one, we have the final sequence x of I into v of n minus I as n minus 0 to 9 we have. Now this is the particular convolution for this signal is x of n convolve with v of n from 0 to 20 pulses here. Now if you see the continuous time unit impulse responses, again we can consider the x of t as input for that particular system and y of t is the output for that particular system. If you consider the x of t as a del of t and the system has the no energy at t equals to 0, the output y of t equals to h of t is called as the unit impulse response of the particular system. Here we'll consider in continuous time convolution integral is. This particular integral is defined by y of t equals to integration from 0 to infinity x of tau into h of t minus tau d tau or t is greater than or equals to 0. Equation y of t equals to x of t convolved with h of t is called as convolution representation of that particular system. Here the block diagram representation of a continuous time LTI system is where the system is having the x of t as an input and y of t as an output for that particular system, where h of t is considered as the unit impulse response of that particular system. For example, we'll consider here x of t as equals to h of t equals to p of t, where the p of t is a pulse from 0 to capital T, which time is capital T. For example, y of t equals to integration from 0 to infinity x of tau into h of t minus tau d tau over t is greater than or equal to 0. First case we are going to consider as t is less than or equals to 0, where multiplication of both the signal is equals to 0. That's why the integration of that particular signal is 0. So we have the y of t equals to 0. Case number 2, here we are going to consider the t in between 0 to capital T, where the multiplication of both the signal is exist in between 0 to t. So we can consider the y of t as an integration from 0 to t delta tau equals to t. Here we can consider the case number 3 again, where t minus capital T is in between 0 to capital T. That means small t is in between capital T and 2t, where your existence period of the both the signal, if you multiply both the signals, we have t minus capital T to capital T, where you can take the integration from y of t equals to t minus capital T to t over d tau, which is equals to 2t minus t. And case number 4 equals in t capital T is less than or equal to t minus capital T, where you can consider 2t is less than or equal to small t. Again here the multiplication of both the signal is equals to 0. So here we are concluding the example with y of t equals to x of t into h of t, where your convolution exists in between 0 to 2t. Thank you.